right, so we are talking today, part one anyway, about domain of log functions. And to do this, I want to go back and sketch the graph with you of y equals to log base 2 of x minus 1, because now that you know more stuff about log functions, this will be easier. So let's take a look at our main point. Our main point is going to be 1, 0, and we will be congruent to y equals to log base 2 of x. Remember that the numbers that we're going to be using for our table of values are 1, a, and 1 over a. So 1, this is a, so 1, 2, and 1 over 2. Now that you know how to evaluate these things, the values become a lot easier, because then we get log base 2 of 1, that's a log property, that's going to be 0. We get log base 2 of 2, 2 to the 1, out pops the exponent, that's 1. You can actually evaluate these now. And log base 2 of 1/2, which is log base 2 of 2 to the negative 1, and out pops that negative 1. So from our main point, we've got ourselves 1, 0. Right away through the main point, remember that there is going to be a vertical asymptote line. You can plug the points in if you want to first, but the vertical asymptote line, excuse me, the vertical asymptote line always goes through the main point, just like in the exponential function, the horizontal asymptote line did. Remember that the asymptote line is like a brick wall, so we've got ourselves x equals 1. So from the main point, sitting right in here, we are going to move right 1 up and up 0. So right 1 up 0 gets me right here to 2, 0. We're going to go right 2, 1, 2, and up 1. So from the main point, 2 over and up 1. That's going to be at 3, 1. And we're also going to go right 1/2 from the main point and down 1. That just gives us the shape of our graph, and we've got a graph that looks something like this. You don't have to label that fractional one. Now the reason why I wanted to do this is now to show you that this table of values, you can actually plug numbers into it now, which is great, but also that our domain, x is greater than 1, is going to be very closely linked to our original function. Our original function was y equals log base 2 of x minus 1. And if you remember, we had this property that said log base triangle of square. So remember that the base, the triangle part, always has to be greater than 0, and the base can't equal 1. The base in this question is 2, so it's safe. But this argument, the square, always had to be greater than 0. So in this case, x minus 1 had to be greater than 0. There's my square sitting right in there. If I add 1 to both sides, I get x is greater than 1, which is my domain for the graph. So you can actually sketch or find the domain for this thing without going in and sketching the function. So we're going to use that property to find the domain for certain graphs. So when we find the domain for certain graphs, we're going to find the domain for this one. Y equals to log base x of x plus 1. Now this one you can't graph. We don't know what the x is, the base down here. It's going to be a bit of a problem. So what we have to do is we have to use this property and the idea of inequalities. So our inequalities are yet back again. We had inequalities in Unit 1, in Unit 2, in Unit 3, no, in Unit 4 definitely, and now our inequalities are back again. So what we want to do is we want to say this. My triangle is x. I know that my triangle has to be greater than 0, and my triangle can't equal to 1. So my triangle is x. I know that this is my square. My square has to be greater than 0. So x plus 1 has to be greater than 0. Subtract 1 from both sides. X is greater than negative 1. Now I've got this guy, and this guy, and they all must be true. And that means that they all must be true at the same time. So we are dealing with an AND situation. Now, if you can see this in your mind, that's great. But what I like to do is look at it on a number line. The numbers that I have are -1, 0, and 1. Let's put them on the number line. First of all, x is greater than 0. Looks like that. Secondly, x is greater than -1. Looks like that. And thirdly, x is not equal to 1. So that sort of takes that spot out. And means where everything happens at the same time, or where they overlap. So hopefully we can see that these guys are overlapping in here and also in there, but not at 1. So that means that my domain for this would be everything greater than 0 except for I can't take the 1. The 1 is sort of coming outwards from that one. And this idea of the inequality is what we're going to be doing to find the domain with log functions. So we are back to our inequalities again. Let's try another one. Y equals to log base 2 of x plus 1 plus log base 2 of 5 minus x. Now we've got 2 logs. We're also not going to graph this one. So what has to happen is that we're going to have to take a look at each one separately. In this case, my triangle is 2. It's safe. In this case, my triangle is also 2. It's safe. My square is x plus 1. It has to be greater than 0, so x has to be greater than negative 1. In this question, the square is different. My square is equal to 5 minus x, and it has to be greater than 0. So you can either add x to both sides, add x, and you would get 5 is greater than x, or if you want, x is less than 5. Or you could go negative x is greater than negative 5, subtract x from both sides, divide by negative 1, divide by negative 1. And if you remember, when we divide an inequality by a negative, it switches sign. You're going to get the same value. This is, again, an and situation. So you've got to get this guy and this guy. Look at it on the number line. There's your negative 1. There's your 5. X is greater than negative 1. X is less than 5. The and situation is in between. Excuse me. And my domain is going to be everything between negative 1 and 5. Okay, so let's step this up just a little bit more. I'm going to take a look at this one. So the next one is y equals to log base, log base x minus 2 of x squared minus 4. So in this case, my triangle is x minus 2. And remember that the triangle, the base has to be greater than 0, and the base can't be 1. So x minus 2 has to be greater than 0, x has to be greater than 2, and x minus 2 can't equal 1. Add 2 to both sides, x can't equal 3. Now, here's the other part. My square is x squared minus 4, and that has to be greater than 0. And then all of a sudden, we are back to Unit 1 when we are dealing with polynomial inequalities. Hopefully this will help you with your review for your final. Remember that your practice final is next Friday. So if we take a look at Unit 1 polynomial inequalities, our steps were set the inequality to an equal sign. So we've got x squared minus 4 equals to 0. We solve it. So x plus 2, x minus 2 equals to 0, x equals to plus or minus 2. We put the numbers on the number line. Remember, you have to tell whether it's open or closed dots. Oh, not dots, dots. So we have our little number line, negative 2 and positive 2. Because of the inequality right here, they're going to be open dots. And we are going to be testing x squared minus 4, x squared minus 4 to be positive. If I test negative 3, 9 minus 4 is positive. I definitely want this section. If I test 0, 0 squared minus 4 is negative. Ooh, I don't want that section. And if I test 3, 9 minus 4 is positive again. I definitely want that section. So when we are looking for our answer, and that's unfortunately not the answer, we have to have this situation and this situation and this situation all together. So again, I like to see it all in a number line. I see it very visually here. So we've got negative 2, we've got positive 2, and we've got positive 3 on the number line. So this guy that we just finished doing said that we had negative 2 and this one. This one over here says x is greater than 2. So right away I can see that there's some stuff that's going away. And this guy right here says x can't equal 3. So here is my domain for this question. My domain is going to be x is greater than 2 and x can't equal 3. So this was my little short review of what a polynomial inequality is going to look like, or what it did look like. You will get lots of opportunity in your homework to practice those, and in your practice questions after this to practice those. Please don't forget the steps for your inequalities, because they are going to be coming back really fast and very soon. Okay. So part 2 of today's lesson is to use your domain to be able to solve log equations. Next class we will solve exponential equations, but today we are solving log equations. A log equation looks something like this. It might say log base 3 of x plus 1 and log base 3 plus log base 3 of x plus 7 is equal to 3. And there are actually two methods for solving a log equation like this. Here is your first method. Method 1 looks like this. You are going to, first of all, use your log properties to combine logs on one side of the equation. That's if there's just a 3 on the other side like we have right now. Okay, so this is what it looks like so far. When you have a plus in between two logarithms, it really means that you are multiplying. So we get log base 3 of x plus 1 times x plus 7 is equal to 3. I'm going to fix that up just a little bit. Log base 3 of x squared plus 8x plus 7 is equal to 3. Now remember that there are brackets around this. This is log of something. These brackets are here. Nothing can come inside there. You cannot bring the 3 inside here because the 3 isn't in a logarithm. So that's your first step. Second step is, now that you have a log equation, what you want to do is you want to change to exponent form. Back and forth. Logs are exponents are logs, all kinds of stuff. So when we change to exponent form, you ask yourself, what's the base? Okay, well, the base is here, so the base is 3. What's the exponent? Logs are exponents. Log equal exponents, 3 cubed. And our leftover stuff is x squared plus 8x plus 7. We are then going to solve. And what I'm going to get is 27 is equal to x squared plus 8x plus 7. So 0 is equal to x squared plus 8x minus 20. So 0 is equal to x plus 10, x minus 2, and x equals to negative 10 and 2. Now, the last thing that we have to do, regardless of the method that you're going to use to solve these things, is you're going to check the domain of the original question. Now, you don't actually have to find the domain if you don't want to, but what you have to do is you have to check the domain of the original question. So my original question was log base 3 of x plus 1 plus log base 3 of x plus 7 is equal to 3. So this guy is a square. It has to be greater than 0. If I plug in x equals to negative 10, it fails, because negative 10 plus 1 is negative 9. So that's out right away. You don't have to test it in the other one. If I plug in x equals to 2, 2 plus 1 is greater than 0. Check. Then go over here to check this guy. This guy has to also be greater than 0. 2 plus 7 is greater than 0. Check. Therefore, my answer is x equals to 2. And if you remember, x equals to negative 10 was called an extraneous root. We sometimes get extraneous roots when we do something to the equation to make it easier to solve. And what we did to the equation to make it easier to solve was we combined our logarithms and we changed to exponential form. So we did a bunch of stuff there. So we don't take that solution. So you always have to go back and check the domain for that one. So that's method 1, okay? Use your log properties to combine all your logs together on one side, change to exponent form, and solve, and then check. Here's method 2. I'll do the same question. I'm going to show you method 2. So method 2 says, let me just write down the question again. Log base 3 of x plus 1 plus log base 3 of x plus 7 is equal to 3. Method 2 says, combine all logs on one side and make the other side also in terms of one logarithm. Essentially, what you really want to get is you want to get log of something is equal to log of something else. Oh, happy cloud. Okay, so the log of this is equal to the log of this, and it doesn't matter what the base is as long as they match. And therefore, by anti-log or comparison, we could say that the square and the cloud would be the same thing. That is the idea beside this one. I don't know if there's a whole bunch of steps, maybe just one step. So what we have here is we have log base 3 of x plus 1 plus log base 3 of x plus 7 is equal to 3. So I'm going to just scroll that up so that you can see it. This guy on the left side is easy to combine because that plus sign means that we are multiplying. So as you saw before, we multiply those two things out and we get x squared plus 8x plus 7. Excuse me. But this side over here, this has to be changed. 3 has to be written as log base 3, because we have to use base 3, of something. And if you know what that something is without solving for it, great. If not, solve this little mini equation here, change it to exponential form. Exponential form. Base is 3, exponent is 3, left over is that little square. So that means that what we get over here is we can write log base 3 of 27. 3 cubed is 27. Again, if you could see that right from here to here, you don't have to show the work on the side. What we have now, though, is we have log base 3 of something is equal to log base 3 of something else. We can anti-log and get x squared plus 8x plus 7 is equal to 27. And so x squared plus 8x minus 20 is equal to 0, etc. And you go back again and make sure that you check your answer in the original question. So this is how we do our questions. I will do one more example for you. We're going to solve. Here we go. I'm going to solve, and we're going to go 2 log base 5 of 3 minus 2x minus log base 5 of x plus 6 is equal to 1. I just want to make sure that you know what to do with this situation. So I'm going to use method 1 first. I'll go through the other one too. I want to combine this whole side here into one logarithm. So remember that we are following BEDMAS. And the first thing that we're going to do is we're going to get rid of that 2. So we are going to go log base 5 of 3 minus 2x squared. The 2 comes up. Minus log base 5 of x plus 6 is equal to 1. The minus sign is what's next. This minus sign sitting right in here means divide. So we're going to get log base 5 of 3 minus 2x squared divided by x plus 6 is equal to 1. Now, change to exponent form. The base is 5. Logs are exponents. Logs equal exponents. My exponent is 1. And my leftover is 3 minus 2x all squared divided by x plus 6. So this is 5 over 1 on the left side. This is 4x squared minus 12x plus 9 over x plus 6 on the other side. If I want to get that common denominator on both sides, I'm going to multiply by x plus 6 and x plus 6. And I'm going to get 5x plus 30 is equal to 4x squared minus 12x plus 9. Bringing everything over to the right side to keep your leading coefficient positive. There it is, my leading coefficient. So we're going to end up with 4x squared minus 17x and then minus 21. Now it seems like a big number, but we know that we have to multiply to 4 times negative 21 and we have to add to negative 17. And I think the numbers are 4 and negative 21. So we can factor this thing nicely. So we're going to get 4x minus 21 and x plus 1. My solutions are going to be 21 over 4, which is about 5 and a bit, and negative 1. Now, don't forget to check. And we don't check in the converted form. We don't check in anything except for the original question. The original question, if you've forgotten it, well, I have. So here, I'm going to write it out. 3 minus 2x, and then minus log base 5 of x plus 6 equals to 1. So 21 over 4 is equal to 5.25-ish. So when I check this guy, it's the square. It has to be positive. And I get 3 minus 10.5 is greater than 0. So it looks to me like I'm throwing that guy out right away. Now I'm going to check x equals to negative 1. 3 minus 2 times negative 1 is positive. Great. So now I'm going to go over here and check this guy. X plus 6. So negative 1 plus 6 is positive. It works in both of those, and so therefore x equals to negative 1 is the solution that I'm getting for this question. If I wanted to do method 2, this is what it would set up like. It would solve the same way. Method 2. It would look like this: 2 log base 5 of 3 minus 2x minus log base 5 of x plus 6 equals to 1. So log base 5 of 3 minus 2x squared over x plus 6. If you're comfortable enough with your log properties, you may go right into this step, but do not skip this step. On the other side, this guy right here has to be log base 5 of something. So log base 5 of something equals 1. If you can't think of what the something is, change it to exponent form. Solve this little equation. Base is 5, exponent is 1, left over is that guy. So that means that on this side, we're getting log base 5 of 5. Log base 5 of happy cloud is equal to log base 5 of 5. So happy cloud, 3 minus 2x squared over x plus 6 equals happy cloud on the other side, which is going to be 5. And then we solve it just like we did before. All right, well, I think you're going to have some questions to try, and I hope they go well. Some practice questions for the quiz as well. And good luck.